This is a pretty straightforward question, but you should be careful too when resolving it. So the part A, to find the unit vector, first of course we need the vector PR. Now the vector PR is defined as the position vector of R subtract the position vector of P, and you should get 1, 0, -1, right? And then you also need the magnitude of this particular vector. So let me tabulate the magnitude. By its definition, we take all the components and square them and find the sum of those squares. It should be square root of 2. And so the unit vector, by definition again, is defined as this. If you take the vector PR and divide it by the magnitude, and the magnitude is square root of 2. So that means that our unit vector that we seek is this one. And you can check that the unit of this vector is, the magnitude of this vector is 1. Now in part B, you are supposed to find the angle of PQR. Let me try to do a sketch here, and I believe this is what the question is asking for, PQR, and this is the angle theta. We asked to find it, and so here clearly the dot product is very useful here. So the dot product, one of the definition of dot product is A dot B equal to the magnitude of A and B times the cosine theta. Now the theta will be the angle between the vector AB. So here we need to find QP, and we must use Q as a start point for both vectors. Using the same method we used in part A just now, you should be able to show that QP at this value, and also QR as a vector is -3, 2, -2. Note that because you are looking for the angle, so you need to use Q as a starting point for both vectors. And so if we look at that particular dot product formula, means that we're going to dot these two vectors and equal to the magnitude of QP and QR and cosine, let's just say, instead of calling data, I call it PQR. Is that nice? Right. So so the angle PQR is therefore the arc cosine, and the dot product, if you perform the dot product, this will be 4 and 3, 12, 2, 2, 4 is 1, 2. So the sum of this this will be 18, and the magnitude of QP is 21, and the magnitude of QR clearly is 9 plus 4 plus 4, so that will be 17. If you perform this calculation now, I think is right here. Okay, perform this calculation. The angle that you seek is 17.7 degrees approximately. So we just correct up to 1 decimal place, that will be suffix. Now the part C, now what do we do with this? Now find a vector which is normal to the plane which contains the point PQR. Let me explain a little bit about this. So suppose we have a plane, okay, it's like a piece of paper that stretch out, flat, and the 3 points PQR are here. So let's suppose this is Q, P and R, and we know that how to find the vector QP. We actually done so in part B, so the vector QR. So again, remember these 3 points PQR on the plane. Now recalling the concept of cross product, if we cross the vector QP and QR, we'll get another vector, or sometimes the other vector pointing the different directions, and this yellow vector would be perpendicular to both vectors. And then that, of course, if this yellow vector is perpendicular to both vectors, it would be there then perpendicular to the plane, the red plane. So that's our idea. And so here we need is the normal. What we're talking about is the normal, which is defined as a vector that's perpendicular to a plane. And all we need to do is just perform this, QP cross. Already we have the vector QP cross QR, and I'll skip the step on calculating the cross product, but I still write this, the definition of finding the cross product. But you make sure that you perform the work as careful as possible and make sure you get the right answer. It's 2 minus 2. You see, these two vectors are from part B, and the outcome would be 2, 5, 2. Now some of you probably use a different order, and you would then get of the vector 2, 5, 2 but negative, because depending on the order of these two vectors being used. So either you get this or that, and hope you try out the questions, and all the best.